First we are going to understand about what is principal focus. We are going to understand about principal focus. So in the very simple term, the principal focus will be that one point. Acha, first of all, we have to understand this thing, that which one is the principal axis? The center one. The line through which is passing through the pole will be the principal axis. This will be the principal axis, which is this one. Okay. Now you see these blue lines, all of these blue lines, which are actually the incident rays, are coming parallel to the principal axis. This one is also parallel to the principal axis. This is also parallel to the principal axis. This is, every one of them is parallel to the principal axis. Now this is said that if some line is coming parallel to the principal axis in the concave mirror, it will be going on one point. All of these lines will be going on one point. Now we cannot leave that one point, right, like that. How will we explain that point? So for that we have just given that point a name, and that is called as the focus point. So which will be the focus point, or which will be the principal focus? That one point over where, if any line is parallel to the principal line, will be converging and meeting, right? That will be the principal focus. But in the convex one, what happens? In the convex one, you see it is a diverging mirror. So the incident lines which are coming, you see this one, this one, this one, they are parallel to the principal axis. All of them are parallel to the principal axis, but they are not meeting directly at the focus. They are not meeting directly at the focus. Instead of that, what is happening? They are reflecting. They are reflecting something like this. They are diverging. So we consider an imaginary point behind the mirror, which will be called as the focus point. Again, which will be that focus point? That will be the point over where we have just imaginary extended up the reflected one, and where all the reflected imaginary lines are meeting up. That will be called as the principal focus. So in this case, this is the principal focus, and in this case, this one is the principal focus. Both one have the principal focus. Okay, principal focus. Now you have to understand the difference, that what is the difference in between the convex and concave one. Then in the case of the concave one, this principal focus point is also called as the real, because it is lying in front of the mirror, right? That's why it is also called as the real one. While in the case of the convex one, it is not called as the real. Then what is it called? It is called as the virtual. Why it is called as the virtual? Because it is lying behind. So this one is called as the virtual, while this one is called as the real. Why is this one called as the real, and why this one is called as the virtual? You have to understand this thing also, because this one is lying in front of the mirror. This one lies in front of mirror, in front of mirror. That's why it is called as the real one. While this one is not lying in front of the mirror, instead it is behind. So that's why we call this as the virtual mirror. Virtual, behind the mirror. How will we understand the behind and the front of the mirror? The reflected portion will be the reflected one, from where the reflection is taking one, will be the front one, while the polished one will be the behind one. So in this case, the focus is behind, that's why it is virtual, and in this one it is in front, that's why we have just named it as real. Both of them are the principal focus only. Now I'm writing the definition for the principal focus, and let's understand with the help of the definition also. Yes, now understand the definition also, what the definition is saying, that it is the point on the principal axis. Yes, obviously it is on the principal axis only. We can see that this line, the large black one which is passing from this point to this point, this is the principal axis, and the focus for both the mirrors is the principal axis. Yes, it is on the principal axis, at which rays parallel to the principal axis. See all of these rays, this one, this one, this one, this blue one, all the blue one, technically all the blue ones are parallel to the principal axis, and that's what the definition says. After reflection, see, they are incidenting on the mirror, and after that this red lights, or we could say the red rays, are representing that they are getting reflected from the mirror, actually meet. In which case they are going to actually meet? In the case of convex, convex, they are concave, they are actually going to meet. Or appear to come from is, acha, appear to come from, which case is appear to come from? This convex one is the appear to come from, because in this case it is not it is imaginary focus, and all of these lines are also imaginary, which is coming to the focus. Actually this is diverging, okay, are called as the principal focus of the mirror. Now you can read the definition once again, and I hope you will get this point. Now what is this new term that is focal length? See, as we were saying that every distance has to be measured. And how is every distance going to be measured? If we would have a center of curvature, then we see there was a radius of curvature. Like for example, if this is a sphere and this is a center of curvature, then from this point to this point, we say that this was radius of curvature. Just like that, we have to measure all the distance from the pole. Very important point I have just said, that is all the distance has to be measured from the pole. Even if you have to measure this distance from this point to this point, from this point to this point, it should be measured from the pole. If you want to measure this yellow highlighted portion, you have to measure it from the pole. You cannot measure it from anywhere. You technically have to measure it from the pole. So in this case, we have to see what is the focal length. If we want to measure this length, that is from the pole to the principal focus, this length, this small length is named as the focal length. So basically it's nothing, but it is just a distance which is in between the pole and the focal length or the principal focus is called as the focal length. Again, I'm repeating, it is nothing but just the distance in between the pole and the principal focus is called as the focal length. In this case, as well as in this case, what will be the focal length? From this point to this point. So this duration, this is small one, will be called as the focal length. Now I'm writing the definition and let's understand from that as well. Let us understand the same point with the help of the definition. What is this saying? The distance from the principal focus to the pole. It should be from the principal focus to the pole is the distance, right? So over here you can say that the distance from the of the principal focus from the pole of the mirror. Okay, it's correct. So what we will say, technically what we will say, that this point to this point, so this middle distance is nothing but the focal length, which is also represented as a symbol, that is f. This is small f, or we could say this is fp. This point was f. Oh, this point was f and this point is P. So we can also say this is FP. That's it. This is the focal length, and you have already understood what is principal focus.